All right, so let's talk about the section 1.3. Okay, and so I think the big thing for me would be we've spoken about how to name points, lines, planes, and then we talked about what it means to be collinear, and we talked about coplanar, and what now we're going to talk about would be line segments and their measurements. And so the first thing is a segment. What is it? Well, a line segment would be a portion of a line that, we could measure the length of it. Okay. And so, if you talk about a line, because it goes forever in both directions, we can't tell what its length is. Okay. It goes forever. So it's infinitely long. So, a line segment, however, we could say, oh, this line segment is 4 inches long or something like that. It's a portion of that. Now it still has infinitely many points, between the 2 points the end points of it. But that goes just without saying. And so I think the big thing is, how would you name it? Okay. And so if you name it, you would give the endpoints and you would put a segment above it. You could write the word segment AB, but most people just put a segment above it, okay, as a shortcut. And so give me the endpoints, put a segment above it, and that's its name, okay? And so if you meet a friend, you'd be like, hi, your friend's name is, Susie or something. That's my sister's name. And you'd be like, oh, Susie, that's your name. So it's segment AB, that's its name, okay? And it implies the shape, okay? The segment is a shape that is going to be between A and B, and that's its name. Now, we can also speak of, your new friend, Susie, and talk about her height. Well, she's 5'7". Okay, cute. But the thing is, the length of your segment, we could talk about its length as well, okay? And so you can talk about the different features of that. But when you're speaking of its length, you could write out that, the name for its length 3 different ways. You could write out the measure of segment AB. So this is the longer way to write it. And sometimes in a word problem, you'll hear that. You hear something like, what's the measure of AB? Well, that means like, oh, it's 6 inches long or something. And so, or they could put an M, because again, math people are like, I don't like to write a lot of words. Like, we're writing a lot of numbers. Let's make what we're doing count. So they have shortcuts. So you got to know the code, so that you can write shorter things and you can know what people mean. M of AB is the measure of AB. And then the very shortest way to talk about the length of a segment would be just AB without anything above it. And that says, hey, how long is the segment? And so you could write 7 inches equals, equals, 7 inches or something like that. So if it is just AB without something over it, or we're talking about the measure of it, that is its length or size, okay? And then if we're talking about AB with a segment over it, this is its name, okay? And so we've got a name. So just like your new friend, Susie, she has a name, okay? And she also has a height, okay? And so there's so many other precious things about her. But we're talking about 2 features of the segment, and kind of bring it applicable to actually people that you may meet in your life. Okay, so anyway, silly. Okay. In math, in geometry, we do have some vocab. And so we want to learn how to talk somewhat competently. Okay, are we going to be perfect? No, but we're trying to grow. And so, from algebra, some things are equal. Okay. And sometimes in math, to say something's equal sounds a little bit silly. Okay. So we're going to use the word congruent. Congruent, I put it in purple here, or pink, is to say, if 2 figures, okay, whether they're a triangle or a circle or a ray or an angle or a segment, they have the same shape and size as each other. Look at them, they're twins. Okay, so congruency or congruent, that's kind of a big topic, and we're going to work with it a lot this year. And so, the example I showed on here is that, hey, look at this. Triangle, ooh, this is kind of moving. Okay, triangle ABC is congruent to triangle DEF. See the little congruency symbol there? Now, you wouldn't say this triangle is equal to that, because that's just kind of awkward, okay? One could say, people don't say it, okay? So we would say they're congruent to each other, okay? That means they have the same shape and size. So I want to link in your head, congruent means the same shape and size, and we use it with shapes, okay? So here we go. Shape and size goes with congruent right here, okay? That's a good thing to link in your brain. If they have the same shape and size, 2 shapes, whether it's a triangle, segment, angle, etc., you call them congruent, okay? But if things are congruent, guess what? We probably have some equal lengths going around, or equal angle measures going around. So if the length of something is the same, you could make it equal. Okay, so let's talk about an example. Again, we will focus on this through the whole year. So don't worry yourself, if you're like, I don't fully have all that goes with this. Oh, of course you don't. And we're just kind of talking about it. We're going to grow in this concept as the year goes on. Okay. So if two segments have the same length, okay, then they are going to be congruent. They're going to be the same shape and size as each other. So if they're like both like 7 inches long, okay, cute. Then they will be congruent to each other, the same shape and size. So how would you write that algebraically? Right here. Okay, if AB equals DE. What do you mean, woman? Well, remember, when we talk about AB equals DE, we mean their lengths, okay? Do you remember I can't spell, LENGTH. There you go. The length is the same if you say that. So wait, what? Okay, go up here, remember? If you just say AB, you mean the length of the segment, okay? If you have the stick over it, that means the name of it. So if you're saying this right here, we're talking about the length. So if the length of AB equals the length of DE, you can say that's they're equal. Where did I get that from? Down here. AB, okay, whoops, I need a pen. AB, that length equals DE. Do you see that they're the same? And then if length of AB is equal, okay, to the length that's maybe they're both 7 inches long or something like that, then that means that the shape, okay, the shape is congruent. The shape AB, that segment is congruent to DE. So if their lengths are equal, okay, like they both equal 6 inches, then therefore their shapes have the same, they're congruent to each other. And so it goes the opposite way. What do you mean, woman? Well, look, do you see that AC, that is congruent to this right here. They have the same shape and size, okay? So AC is congruent to DF. Therefore, the length of AC equals the length of DF, okay? So congruency has to do with the shape, okay, and size. And then length is equal, okay? And so it's a little bit weird. You're like, they kind of mean the same thing. Again, you would only say these two triangles, you wouldn't say they're equal, you would say they're congruent because they're the same shape and size. And that to me is a little bit more clear than when we talk about segments. Now, okay, we're not going to just put these away right here. Okay, so do you see these 4 little segments down here? Okay, and we can talk about their names and like, oh, look, their shape is a segment. Do you see that AB and EF are the same shape and size as each other? I put this hatch mark, okay, or this tick mark right here to mark this right here. Just one tick here and one tick here to say, hey, look at, they match, they go together. As we're doing shapes, sometimes we'll put hatch marks or tick marks on them to link them together visually. So like, oh yeah, those guys go together. So if you want to talk about their shapes being congruent, you could say, oh, segment AB is congruent to segment EF. They're congruent. They're the same shape and size. Cute. But we could also talk about in terms of their length. The length of AB equals the length of EF, and they both are 1.7 centimeters. So about the same shape, okay, the same person, you can talk about their name, okay, and their shapeness. We can also talk about their size, okay? So therefore, for 2 segments to be congruent, okay, we can do that. And then notice we talk about their names, and then for their lengths to be equal, okay? Congruent means same shape, size, and then length would be equal, okay? And then we could do the same thing with CD. Look at CD, I got 2 hatch marks on there. It pairs up with GH, so therefore shape, segment CD is congruent to GF. They have the same shape and size. But if you're talking about their measurement, okay, you say the length or the measure of CD equals the length or measure of GH, and they both equal 3.5. So we're gonna grow in that concept. Okay. On the back, we said, okay, between the points, if you got to be able to read the sentence, it says point C is between A and B. Okay, well, then you put A and B on a line or a segment or something, and C is going to be in between them. It doesn't, you don't, unless they tell you, it may not be halfway, it may be closer to B, it might be closer to A, it might be halfway, who knows? But we just know that if they say C is between those guys, do you know how to draw? And on the back of your homework, the top 2 questions, they ask you to draw that very point. So I would say definitely look at this and say, okay, they say one point is between 2 other points. So you draw the 2 points and put the other one between it like they tell you, okay? And so another thing to talk about is, hey, guess what? Did you know, if you took 2 friends, you're like, okay, let's have them stand on each other's shoulders. How tall would that be? Well, you plus up basically the height of one of the kids from their feet up to their shoulders, and then the next kid from their feet up to the top of their head, and say that's going to be how tall that little tower is going to be. Somebody stands on somebody else's shoulders, you could add their 2 heights, or their partial heights. according to how they would be towered. And you'd plus them up, and that would give you their overall length. Okay, and so what do you mean, woman? What I mean is this, okay? If you want to find out total length, this total length of something, PQ, how would you get it? Well, you'd sum up the parts. The sum of the parts equals the whole entire length, okay? So we could say, well, if the whole class lined up, okay, and put arm to arm, hand to hand, and just made like a human link, okay, across like the whole school, how long would our human link be? Well, you'd plus up each of our wingspans, and that would be how long of a human chain we could make. And so you add up the parts, and that will give you the total. And so that's something that it's a mathematical truth that I think you probably knew. If you add up the sum of its parts gives you the whole. Okay, so add up the parts that make it, and you get the whole thing. And so when we're talking about segments, like down here, we're going to say, okay, well, if it asks us to find AC, well, we take AB plus BC, and that will give us AC. So the length of AC is equal to 10.1. Okay. So you add up the two lengths, and that will give you the total length from A to C. Sometimes you've got to form an equation, like on number 2, you could say, okay, the sum of the two parts, these two little parts here, if you look at this part right here, from F to G, that part plus X, what does that give you? The whole length. The whole length is 15. So 9.7 plus X, the part we don't know, gives us the entire length together. So if you add up the two parts, you equal the entire length there. And so you could solve it to say, well, then what would X be? Okay, GH or X in this case, either one could be fine, would be 5.3, and we should label it, okay, as millimeters, okay? The next thing would be, notice those little hatch marks. Do you remember we use hatch marks on the bottom? I can't talk. Hatch marks on the bottom of our notes. Okay, where? Well, let's talk about this over here. If I can get it to move. The hatch marks link things that are equal in length. So like this one goes with this one here. Okay, so when we look over here, do you see the hatch marks on number 3? Okay, do you see this has a 1 hatch mark? And that means these have the same length. So if this is 4.6, this has got to be 4.6 as well. So if they want MO, you would just add the two parts to get the whole length. So it'd be 9.2. I thought it said 4.5, so I had to redo mine. So 4.6 plus 4.6 is going to be 9.2. Again, for this, these two hatch marks show you that both those segments have equal length. So therefore, if you know the whole length and you know each of those are equal, you can write an equation to find out the side, or you can kind of say, well, I know I have to divide by 2, because if the whole is that and it's split into 2 equal pieces, well, divide it by 2 to get your answer. All right, so now we move into the interesting things. Okay, it says, hey, the sum of the parts, so this part is 5 and this part is X, so 5 plus X gives us our total. So the sum of the parts equals the total. We'll solve for the part. And so the answer is X, and X is 7 inches. And that would be this first answer. Here are the sum of the parts. So what are the two little parts here? Well, this part is 14, and this part is 2x plus 1. If you plus the two parts up, or as many parts as there are, that will equal, the sum of those two parts will equal the entire length. And so 14 plus 2x plus 1 gives us the overall length of 3x minus 5. And so solve it using your Algebra 1 skills. So combine like terms on the same side. 2x plus 15 is equal to 3x minus 5. Let's get the x's to one side by adding or subtracting. Let's get the number terms to the other side by adding or subtracting, and you get the value of x. Now, it's possible, and this is going to be centimeters, it's possible that, actually it's not in centimeters because it's just x. That is great. Sometimes it says find x. Sometimes it says, well, use x and find actually a value. What if they asked you to find out the value of mn? Well, mn is equal to 2 times x and then plus 1. Do you see that? They said, oh, after you find x, use it. Well, they didn't, but I just want you to see this. And so you would do 2 times x and add 1. So x is 20. We just found that. So you do 2 times 20, and then you add 1. So 2 times 20 is 40, okay? Plus 1 is 41. So mn, the length of mn is equal to 41, and that would be centimeters. So sometimes they say just find x, and in this case they did. But I want you to say, if they ask you to use x and find something else, well, then you just plug it into your expression to find out what you need to. Okay, so the rest of these are pretty similar, but you've got to read. Okay, it says, oh, if this is the part, this is a part, and the overall total, RS, is going to equal 24. So you plus up these two parts, and it equals 24. Okay, add those up, and then set it equal to 24. Combine like terms and solve. You can find the value of x. Okay, so x is 3. And then it says, can you find RT while you're at it? We'll plug in 3 up into this expression. So you do 6 times x and minus 4. So 6 times x is 3. That gives you 18. And then minus 4, you get 14. So that's basically what we're doing. You can kind of read through some of these other questions and be like, okay, how are we doing? You know, are these collinear? How would you set this up? You can see if it's halfway between, it splits it up into 2 equal pieces. So if we're half done with the hour, you're like, oh, what's behind me and in front of me is the same distance of time. And so that's how you do this. So you just kind of do 6,000 plus x plus x. You may solve that equation. I think the main thing is if it's collinear, you know, they're on the same line. If it's between them, you don't know necessarily that it's halfway. So just be careful with that one. And then the difference between regular AB, that means the measure of AB, its length. And this means the segment or the shape of AB. Okay, and so those are the main things. I think on your homework, I mean, I want to say people struggled a little bit with number 6. Because it doesn't give you a total. If you add these up, it would equal the total, but we don't know that. Okay, so what else do we know? Okay, and sometimes that's part of geometry is like, what else do you know? We know these 2 segments are congruent to each other or equal in length. Why? Because they have the hatch mark. So you can write, oh, I can't write unless I choose a pen. All right, so let's write 3x minus 6 and set that equal to 2 and then x plus 1. And so once you distribute and solve that for x, then you can be done, or you can plug it back in to find the length of each function or each segment. Okay, so next thing I would suggest is this. Remember, number 8 is going to be this, the sum of the 2 parts equals 15, the total. Now I'm going to tell you, on 8 and 11, your value for x will be a negative number. I think the value for 8 is like negative 8 or 7. I cannot remember what it is. I don't have it close to me right this second. But let me see if I can find it. Yeah, it's negative 7. But if you plug in that value to each of these expressions, you'll notice the segment length is not negative. X is allowed to be negative. Okay, we learned that back in Algebra 1. However, the length of a segment is not allowed to be negative. And we know that just from like being alive. Okay, so we know that too. Number 11, again, you're going to do the sum of the 2 parts equals the total. Okay. And you can write that equation and solve it. But when you solve it for x, your value for x will be a negative value. However, when you plug it into your expression to find the value of DC will be a positive length. Okay, so don't have a heart attack when you see that. I saw that. I was like, oh my heavens, what are we doing to these children? So the next thing is draw a picture. It says point B is between A and C. So if you draw this, you draw A and C, and point B is where? Between it. I don't know if it's halfway or just part way or whatever it is, but B is between it. Now label your picture, and again, you're going to know AB and BC, and you're going to plus AB plus BC and set it equal to the overall length from A to C. Okay, so AB plus BC, the sum of the parts equals the total. All right, what else do we need to say? Oh, and the answer number 12 for X, it rhymes with hero. Okay, so it's kind of a weird answer. But again, your lengths of the sides will be completely fine. So just some of those weird things that I just wanted to point out to you guys. Okay. The last thing I would say is that when you're drawing these things, make sure that when you draw this plane right here, okay, you're going to draw a plane. You're going to use a ruler to be super cute. You're going to put some points on here. You're going to draw some lines. And it says, hey, this plane does not contain point P. So if you want a point not to be on a plane, you can't just put it over here. Because what if you extend the plane like planes do? How do you know that it's not going to swipe and put that on the plane? It says it's not on there. Okay, and so in class, if you were in class, you would have noticed that I'm like, how do I make sure like this box right here doesn't touch my desk? Well, you prop it up on top of, I put it on top of my hand sanitizer. So how can you prop up a point so it doesn't touch the plane? Well, you put it on a tower. So can you draw a little line that kind of goes through there? You draw like arrows right there. So put a stick, okay, like stab a stick through that piece of paper, through that plane, and put the point P right up here on that tower so it's far away from the plane. Okay, so that's how you make sure that your point P does not even touch the plane. You put it on a tower. Okay, so that's my notes for today.